അവിടെ ഇല്ല ഞാൻ നോക്കിയത്
അവരെ പറഞ്ഞ കാര്യം ആ പടമുള്ള 4 പേര് പോലീസുകാരാണ്. അതിന്റെ ഇടയ്ക്ക് ആൾക്കാർ അവർക്ക് പോലും നിയന്ത്രിക്കാൻ പറ്റില്ല. ഭയങ്കര യുദ്ധമാണ്. ഇത്രയും നാളിനിടയ്ക്ക് ആദ്യമായിട്ട് ഇങ്ങനത്തെ ഒരു സംവിധാനം ചെയ്തത്. ഭയങ്കര ഭയങ്കര എരുമേലിയിൽ 5 മണി വരെ നോക്കാം. അത് കഴിഞ്ഞിട്ട് ഇവിടെ വന്നിട്ട് പുതിയ സംവിധാനം തിരുപ്പതി സംഭവമായിട്ട് അവിടെ ക്യൂവിൽ പിടിച്ച്.
Good evening, all.
Good evening, madam.
Good evening, ma'am.
Very good evening. So, yeah, let's start. Okay.
Good evening, madam.
Yeah, very good evening. Okay. So, today's session and a few forthcoming sessions is all about business analytics. Maybe, like few of you have heard this term, like in your office work, in your office environment or in your work environment, or you would have heard about this, like in other social medias, through your neighbor, through your colleagues or through your peers. So, what is business analytics all about? So, how does it help the organization? And what is the objective of doing analytics on the business operations of the business? So, we are going to see about that. And let's start. Okay. So, here I have listed out all the objectives. So, first we are going to see about what is analytics is all about, the exact meaning or the definition of analytics, to understand the evolution of business analytics. So how it all started. So that should be a point where organizations, like all over the world, they may feel that they need something more for, to go on with their, activities. To help them with in decision making, or to help them with like forecasting, to help them with deciding on cost factors and everything. So how it all evolved and what made the organization to adapt to the business analytics model and to understand the data analytics methodology. So how it is done. There are no methodologies followed. So how it is done, to discuss the different roles of analytics in various industries. So it's not the same in all type of organizations. So each industry, they will be having their own way of analyzing their business operations. And obviously that would be helping them in other ways. There is no in decision making, in capital investment, in giving out the in profit sharing, and in selecting the right kind of suppliers or vendors, or selecting the right kind of distribution channels, or to keep a very good relationship with the customers and their service providers. And finally, to identify the challenges and opportunities of analytics in different sectors. So what are all the challenges and what are the opportunities available um, in the business point of view in different sectors, in each and every industry, or in each and every type of organization, based on their activities. So this is the objectives. Let's start. So first we are going to see about the definition, the actual meaning of what is business analytics. So it's a process by which companies use data. So data here, it refers to the past data, the present data collected from the market or from the customer in the form of feedback, or in the form of when a sales increases, obviously the company will come to know that their products are doing well. So whatever the factor is, so uses the data. So data has to be available in hand. In few cases, the companies in forecasting, while forecasting the demand no, for future, sometimes few companies they don't take data for consideration. They don't take the historical data or the present market trend for any consideration. They just go on with the same old way of no like whatever has been no like done before. They would just repeat the same pattern, whether it is procurement or production or no like storage or distribution. They would just go with the same pattern. There will not be no like any increase or decrease in their no like the production factors or in their no like service factors. But few most of the companies they will be using their historical data, the past data, that is their operations and their the product or design and the service and no like other factors they have provided to the customers. So what is the customer band they have no like they are targeting and what market segment they are no like focusing on. So these data will be collected and based on that data, the forecasting will be done. So, but for business analytics, obviously data has to be in hand. Without data, it is not possible to do any analytics. So this data is either created by their operations or publicly available data. So either by organizations' operations, the past operations and the present operations, or sometimes directly it will be like collected from the market. It may be collected from the distribution channels, the retailers, wholesalers, how their product is moving on, or it may be directly collected from the customers and the consumers who are no like the final users of the product. And why this is done? To solve business problems, monitor their business fundamentals, identify new opportunities for growth, and better serve their customers. So for these reasons, yes, the data is collected. So it is either by the company's own operations, past operations, and the present operations, or it is no collected from the market or from the customers or consumers directly. So based on this data, the analytic analysis part is done. And second point is it's a type of analytics that helps organizations mine. Mining is something, no, like you're extracting something, no, which has already been there. So mine, process, and visualize important business data and take advantage of patterns in their businesses that would not see otherwise. So mine the all the factors. So okay, extract all the factors, extract all the activities and the operations which has happened, and whatever process has been like whatever process has gone through, and everything will be like collected, and these this would be like patternized and like this would be like taken for consideration. The third point is business analytics involves either individual pieces of data or data sets which are either stored on premises or in the cloud. Either the individual pieces of data, so stored here and there, pieces of data stored here and there. Maybe like if there are like multiple departments in an organization, finance department will be holding some data, and the HR department will be having like another data, maybe related to the like the PF or whatever it is, salary, wages, increment, and appraisal and everything, and the other departments will be having some other data. So all these pieces of data are like collected, and like all the data sets which are either stored in premises. So these pieces of data, everything is collected, or the data sets which is already stored in the cloud computing. You might have heard about it. So it's like a database, an internet database. So this would be collected for doing the analytics purpose. Then fourth point is data sets that increase beyond a certain threshold or commonly referred to as big data. So now big data, machine learning, AI, and like prompt engineering, and what else? No, NLP, natural language processing. So these are the new terms, like right now, which is happening in the like this is a recent trend in the technology. Okay, this is a recent trend, no, which is happening right now. So any operations or any activities which is related to like production or manufacturing or procurement or transportation or the product design or customer, customer feedback, or the market segmentation, the demand forecasting, or predictive analysis. So at least one of this factor is connected with any of the newest technology, which is being, like listed. It must be, like AI, or it must be related to this big data, or it must be, like related to what else, like many new things have not come. So some data, like it increases, like up to a certain limit. I mean, even more than that limit. So sometimes even the cloud computing will not be, like they will not be, it will not be having no enough space for storage of such data. So on the everyday basis, like so much of data is being generated by individuals, by the companies, by the agents, by like almost all sectors in the world. So much data is generated, so there is no available storage space in the normal computing system or in the cloud computing system of any organization. So to hold and to preserve these, like data which has crossed the threshold, big data is being used. So this big data, it requires significant computational power to access and analysis. Obviously, it requires a significant computational power. Then fifth point, final point is business analytics uses data exploration, data visualization, integrated dashboards, and more to allow users access to usable data and insights. That is data exploration. So whatever data is available or which is collected, so exploring the data and visualizing the data, whatever pattern the organization wants to view or an individual wants to view. If they want to see the visualize the data in tabular format, so the machine like gives the output. Or if they want to view the data, visualize the data in like in a bar diagram format, yes, that is also available. Or in a like like the chart format, that is also being like it can also be collected from their system. Okay, so whatever like whatever the organization or any individual, how they want to visualize the data, so that is like made possible with the use of like all these new technologies. And of course this will be helpful in helpful in analyzing the business operations like very easily. And integrated dashboards. Integrated dashboards is something like servers. So all the departments in the organization can easily connect with one another, and like they can share their views. They can like save their like work. They can save their work in the centralized dashboard. So uh, so if you see overall, if you see, the business analytics is all about collecting the data, whichever has like those data. It is based on the activities or the operations which has happened in the industry, or which has happened in the market, or which has happened in the national economy or world economy or whatever, and in each departments of the company. And so collection and visualizing and mining of this data. So based on these data available, the demand forecasting or the output is like taken, and based on that decisions are taken. So there are four types of business analytics. First one is descriptive analysis. So this descriptive analysis is completely based on the past historical data. So whatever has like passed, whichever has passed on. So this descriptive analysis comprises of those data. This is not already done, and this data is not like already feeded in the computer system, or it is not like automatically. No, it is already documented in a digitized format. So this type of analytics helps organizations understand what has happened in the past. It involves analyzing historical data. So why this is collected, why this is no like visual, I mean, why this is mined to identify the trends, patterns, and relationships which has happened in the past. This is not for forecasting, but the company here, the organization is, like trying to understand what trend has happened before, what pattern of, like the sale or what pattern of the demand has happened before, and other relationship, the companies, the organization's relationship with the customers, with the vendors, with the clients, with the shareholders, stakeholders, with the consumers, and with like other service providers. No, what was their relationship in the past? So this is completely mining the past historical data, descriptive analysis. Next one is the second type is diagnostic analysis. So this analytics is being done to understand why that thing has happened in the past. So what has induced that factor which has happened in the past? So why that has happened? So what was the factor? So which what main factor has contributed a lot for that thing to happen? It may be related to the procurement, or it may be related to the resource mining, or it may be related to the uh, production, higher production or lower production, or it may be related to the storage of the goods, or or directly sent from the factory to the consumer, whatever it is. So why it has happened? So what made the organization to make that kind of decision? So analyzing all these is diagnostic data. The third type is predictive analysis. So based on the past data, what is likely to happen in the future? That is predictive. Predictive means it's always related to the future. So prediction, what is going to happen? So that is prediction. So based on this past data, so if the same input is being given, or if the same trend follows, or if the same trend or season, or the demand sustains, so what is likely to happen in the future? So this is no predictive analysis. It involves analyzing data to different identify patterns and relationships that can be used to make predictions. And this is useful for forecasting. So prediction, forecasting, what do you say, a kind of simulation. So what will happen? So how it will happen in the future? So this is all about the predictive analysis. And finally, the fourth type is prescriptive analysis. So prescriptive is, so now the data is mined, data is in the hand right now. Now the organization understood what has happened in the future, and which factor has made that happening, which has happened in the past, and what will, based on that past data on the present trend, what will happen in the future. So prescriptive is the analytics is all about what actions to take to achieve a desired outcome. So if the company has procured, say, a raw material, like 50 bundles of cotton as a raw material, and they have produced, say, 10,000 units of a product, and they have sold around 9,500 units of the product, say, 500 products has been, left out in the warehouse, and it has become a dead stock or obsolete stock. Maybe the trend would have changed in the market. So this is the past data of an organization. Now, prescriptive analysis helps the organizations to understand, okay, if 10 bundles of cotton is being procured, so this will be the result. So why don't we go for, if the number of consumers is going to increase, why don't we go for more than 10 bundles of cotton? Why don't we increase the production? So already what has happened in the past was around 500 units has been left to become a dead stock in the warehouse. So this time the company will make a decision that not even one single item has to be left in the warehouse as a dead stock. So all the items has to be delivered to the market or to be sold to the final consumer. So they will take actions related to that. They maybe they will go with any marketing strategies like bundling, product bundling, or product kitting, and they may advertise more so that they make sure Not even a single product or a unitized product is left out as a dead stock or an obsolete stock. So this is prescriptive analysis. That is what actions to take to achieve a desired outcome. And it involves analyzing data to identify the course of action. Guys, please mute your audio. Let me check who has not muted it. Okay, fine. Okay, so prescriptive analysis, it involves analyzing data to identify the best course of action to take in a given situation. So obviously, the company or the organization will be having like more than one or two options in hand at that point. So they can choose the best course of action so that like there is a minimum wastage or like they can minimize the risk happening in the future. And this is useful for optimizing business processes and improving decision making. So four types is descriptive, diagnostic, predictive, and prescriptive. So descriptive is all about what has happened in the past, and the diagnostic is all about what factor or which factor has induced that happening which has happened in the past. And predictive analysis is what is likely to happen in the future, and prescriptive analytics is about what actions to take to achieve a desired outcome in the future. Clear? Is it clear?
Yeah, clear. And also,
Yes,
I have
ma'am.
one question. So
Yeah.
these business analytics, there is any chance the companies take all these four analysts? Like it is like,
If the companies are using big data technique, yes. So all these four types of analytics can be, it is done. Say any company, even like few companies know the like a normal company which doesn't have to store terabytes of data in their computational system, so they don't have to store like such huge data, so they don't need big data to big data to calculate everything and give them the result. So few company, I mean, those kind of companies, they don't have to completely rely upon this big data or any new technique, or any new technology, which is happening in the technology industry right now. Say, normally there are like many softwares to analyze the, like the historical data and the predictive analysis. It's normally done by, like almost all the production companies. Almost all the production companies do it. Big data makes it very easy. Big data makes it very easy, and it collects the small data, which is being stored in, like different places in the organization or different computational systems in the organization. So in that case, normal calculation, without using these techniques, it will be difficult. So with the help of machine learning or big data, or with the help of AI, the computational process will be like quick and easy. That's the only difference. Otherwise, normally if you see any production companies, they go with like past historical data, what has happened in the past. I mean, in the organization, the sales of the sales part of the organization, what has happened in the past, and how much the company has made profit, and how much raw materials has been procured in the past, what was the result, and diagnose everything, what has made the organization to take such kind of decision regarding the sales or regarding the advertisement or regarding like installing more machineries, and like what based on past data, so they will predict what will happen in the future. And then finally they will go with prescriptive analytics also. I mean, not using the big data concept, they can like very well use the prescriptive analytics. So this is like extensive, this kind of process is very extensive when the organization is like huge. or when the data which is being processed, that is huge. So in that case, of course, yes, big data is required for easy computational purpose, or the help of AI, or machine learning or data mining, whatever. No, so that would be very helpful for the organization. Got it?
Yeah, thanks.
Okay, ma'am, got it.
Yes. Okay, I can proceed. Let's move to the next slide. Okay, when did analytics start? How it all started? So, we know demand, the forecasting, or demand, and the data collection and everything. For everything, the basis mathematics and statistics. So without mathematics and statistical calculations, this will not be this is not made possible. Okay, so with the origin of statistics, in 1700s, slowly, to move on to 1900s, Turing machine. That is the first generation of computational system. So it all started there. And machine learning, it started off by, late 1960s and the early 1970s. So machine learning started there because by the time, because, many companies started their production, in a full-fledged. More production was going on, and because of this automobile manufacturing companies, more production was going on, and they wanted something to help them with the computational calculations. They want something to help to analyze what will happen in the future, to predict what will happen in the future. What is the future of the organization? What is the future of a particular type of product, of the organization? So how to enhance the product? So what is the customer's preference? So if the product can be enhanced in this way, what will be the sales level in the upcoming season? So for this, they needed some kind of technological support. So machine learning started in those days, late 1960s and the early 1970s. Then after that, we very well know, in the late 1990s, the internet, that's a period of internet. So everywhere, the internet was happening. Internet itself is a big data. That's a big data, the collection of all the data, all over the world. It's a collection. And then, slowly deep learning AI, it started off, by 2005 or 2004. So though the study was going on by 2000 itself, it was it got more attention for the the programmers, or the the AI developers in after 2005. So many people started working on it after 2005. So now it's the the era of AI, deep learning, NLP, natural language processing, and data and everything, prompt engineering and everything. So this is how all it started. So as per the Harvard, guys, please mute your audio. Ramesh, please mute your audio. Okay, good. So, if you ask me, should we study data analytics or business analytics, as a, a crash course, or as a separate study to, stay in the organization, or to be, competitive in this, technological environment. So, what I would suggest is, get to know about it. So you don't have to be, a scholar, or to be a hi-fi person in this business analytics techniques and everything, methodologies and everything. But you have to know what it is all about. To overcome the competition. Because in another 2 or 3 years, you can see everywhere these new technologies is going to take up the whole world. in everything, let it be the IT sector, or let it be the educational sector, or let it be any sector, production sector, or let it be, like oil refinery, whatever, infrastructure, take any sector or any industry. So this new technologies, new techniques, definitely they will be having a hand in there. So getting to know about this is very important to know, like stay ahead of the your colleagues and know your competitors within the organization. So getting to know, because more persons or no, like they are predicting they need at least 4.5 lakh professionals are needed for this job in next 2 to 3 years. So it's better to get to know about what is all this about. Okay. So it involves three things: statistics, the basic statistics, computer science, because a little bit of know like how to operate the system, or know how to do the basic computational practices, know that is required, and you need the data. So with all these three in hand, if you know the technique, if you can understand, know what it is all about, so it's very easy for you to understand the whole concept. So make use of this opportunity. You have no like small crash courses, free courses available in the internet. You can now find it in Instagram, and you can find it in LinkedIn. Many crash courses are available. Hardly it will go for no like 10 to 15 minutes, or it may not go for 1 hour, 30 minutes, or no like not more than that. So just just click on any of the free crash course, and know like let to know like let understand what it is all about. That is okay. That would be no like more than. Okay, so what is analytics? It's an encompassing and multidimensional field which uses mathematics, statistics, predictive modeling, and that is forecasting models and machine learning techniques to find meaningful patterns and knowledge in recorded data. Again, here, without data, it's not going to happen. You cannot blindly predict something, no, like based on the trend which is happening, or you cannot blindly predict, no. For example, a few minutes before I was saying, in another 2 to 3 years, this AI, machine learning, this big data and everything. So this is going to know like uh, be like rule the whole world. Everything, everywhere you can see this. So this is not just a statement. This is not just a like a predictive statement, or this is not just a or a forecast statement. So this thing is based on many of the data analytics. So many data analytics that's been done, and it has been proved that yes, in another 2 to 3 years, this is going to be the future of any industry or future of any sector. And to know like perform these activities, yes, of course, 4.5 lakhs people are needed. I'm telling about only in India. I'm telling 4.5 lakh people needed, professionals are needed only in India. Would not think about the whole world. So that is no like more than no like anything. So obviously analytics with the help of data. So data is necessary for doing any kind of analytics. That is the actual data it has to be available, which has happened in the past or which is happening right now, recently, which has happened. So what does a business analyst do? What is his job? What is his, like, what is her job, or the roles and responsibilities? How to make use of this, the available technique, like for make, like for going on with the decision making concept, or for predicting the demand, or for forecasting the demand, or to decide on, like all the other factors in the organization. The first one is, what are the types of customers who buy a certain product? So that would be, this is an example. This is not actually, this is not the only thing which is going to happen. I've just given an example. So it forecasts the sales, and it gives an idea about what is the most bought product, and it gives the organization's inventory report, and it gives an idea about what are the types of customers who buy a certain product. So all these things, it is collected and it's stored as a big data. If the company is big, say Amazon. Amazon is a multi-dimensional company, and of course they will be like using big data, because the amount of data being processed is more in terabytes. So obviously they need big data. So uh, they cannot get an clear idea about from India how how what is the like analysis, from Australia what is the analysis, from China what is the analysis, in US what is the analysis. It's very difficult for the computational purpose. But with the help of big data and business analytics methodology and techniques, it's easy for Amazon to uh, get the results like as soon as possible and make decisions on that. So business analyst, so this person draw conclusions from the data available. So based on these conclusions, the decisions will be taken upon. This is how it works. It helps the organization. Okay, so we are saying about the areas of analytics: forecasting simulation and test analytics, data mining, statistics, optimization, visualization. So everything is connected with data. Data visualization, data optimization, data statistics, data mining. So test analytics of data and forecasting simulation. Again, it's not related to data. So forecasting simulation is nothing but like forecasting, that is predicting the actual, not the actual, but uh, with the help of simulation techniques or with the help of simulation analysis, predicting, okay, this would be the volume of sales which will be happening in the forthcoming season. So this information, yes, it is got from the any like the business analytics techniques. The next one is test analytics. So select any of the test analytics and apply. So that would be decided by the either the department of the organization or by the management of the organization. Then data mining. Data mining is extracting the past historical data which has already been fed in the organization's computer system. And statistics, apply all the statistics method, the data statistics method that the system will take care of. No, you don't have to worry about it. All you have to do is extract the data, give that data feed to the system, and give your orders like what has to be done. The computer, the system takes care of everything. And optimization, that is data optimization. So whichever part or whichever factor you want to like optimize more, you can get more information on that. For example, you have data from HR department, you have get data from the finance department, you have data from operations department, but you would like to get more data from operations department. That is like made possible. So data optimization and visualization. So how do you want to visualize the result? So for example, I would like to visualize the result in percentage format. How much percentage of sales will happen? So that is like available. That will be made available by the system. Or another colleague may be interested to see visualize to visualize the sales which is happening as a bar diagram. Or another person will be liking to visualize in a demand pattern or in the sales pattern. So a graphical representation, like in a chart. Okay. So whatever like I want to visualize, or any person in the organization want to visualize, so that would be made possible. So it's easy and quick for the organization. So this is the analytics life cycle. First, identify and formulate the problem. So here, it doesn't have to be a problem at all. Like the organization can simply go with no forecasting. So there doesn't have to be a problem at all, actually. So the first season is over, the past season is over. Now the organization is like preparing for the next season. So identify or formulate the problem, or identify or formulate the next business cycle. And then data preparation. Prepare the data, collect the past data and everything. Data exploration, explore all the data which is being collected. Transform and select. Transform those data into whatever pattern you would like to visualize, and select the right appropriate kind of visualized pattern. Then build model. Based on that pattern, build a model and validate the model, update the model, enhance the model for better results, and deploy the model, execute that model, implement that model, and evaluate and monitor the results. So this is usually done in business analytics. So the business analytics, no, it is done as a project. So for one particular season, this business analytics is done in this way. So once that is done, and then no, the next process or the next cycle that will continue. So who are the guys no involved here? Business analyst is involved, and the roles and responsibilities. So business analyst does data exploration, data visualization, report creation, and we have data miner or statistician, and the job and responsibility is exploratory analysis, descriptive segmentation, predictive modeling, and we have IT or systems management or systems engineer, and responsibility is model validation, model deployment, model monitoring, and data preparation. And finally, business manager, what this guy, that's it, domain expert. He's the or she is the domain expert, makes decision which is no like done with by the computer calculations. So makes decisions and evaluates processes and ROI, that is return on investment. So this is how it's done in business analytics. Okay, so this is a prediction actually, big data statistics. So by 2025, there will be like around, this is again a predictive analysis, and this is not just a mere speculation, again, based on the, what do you say, based on the techniques, methodology of like analysis, using the business analytics model, this is being predicted. So by 2025, the whole world is now like expecting around 70 trillion gigabytes of data, that will be generated, and it has to be stored. So such a kind of storage space we need. So the present storage space which is created by the present computational systems, uh, this is not okay, or this is not enough. So we need more. And in 2012, it was possible for the IT people or for the technology people, technological savvy people. So only 0.5 of all the data was analyzed, and the remaining data, like it was just staying raw. They couldn't do much calculations, or like it was not even touched. So, but now with these new technologies, yes, even like terabytes and gigabytes of data can be, zettabytes of data can be compute, like completely like analyzed, and no results can be drawn. And 2.5 quintillion bytes. I don't know like how much quintillion is all about, but this is the like a prediction they have given. Quintillion bytes data are generated each day by internet users. So, for example, if I search one particular a word or an event in the internet, so that comprises one data. Or if I'm a prompt engineer, and I'm using any prompt engineering use case or something, like I want this, give me a content for this, or like give me a beautiful design for this. So each one is like data. So this data is being generated all over the world. So on a daily basis, 2.5 quintillion bytes are being generated. So there has to be enough space, like in the internet platform to store all these data. So that is called big data. That's what the companies are working on it. So in 2019, there are 2.3 billion active Facebook users, and they generate a lot of data. Consider like the Facebook or the what you're using when you're using like other applications like what do you say, that Instagram or whatever it is, like when you're using your computer system for generating any kind of data. So again, it's a like a massive data collection. So that's where big data helps. Okay, why does it matter? So we have already seen. So it's a term applied to a data set that exceeds the processing capacity of conventional database system. The old database system models, like starting from DB system, database system, to Excel, and then to what do you say, like SQL, and then you have many things lined up. So I think even a newer version of Java also supports like the database in this thing. So those are conventional models. They don't have enough space for the storage of all these huge volume of data which is being generated. So of course we need a big space. Big space should be available for storage of like all these data which is processed. It doesn't fit the structural requirements of traditional database architecture. Again, there is a point where you cannot fit everything like to one particular thing. So for example, if you are using a data from HR department, so it can be incorporated or integrated with another data from another department with the help of like ERP systems. So ERP systems, that's the same thing. It gives you a end result based on the data collected from each and every department or each and every factor. It does the same thing. But when there is like an increase in the data, there is an extensive data, you cannot completely rely on the ERP. You have to go to the better option, which is the big data. So this is how it works. It's a visualized model, like how big data works. So this is the normal data by the traditional, whatever it is, like Excel or whatever software it is. This is how it is done. And whatever calculations we get here, it's in the same app, same application. So whatever results we see here, by calculating all these, it's in the same application. For example, if I'm using Excel to calculate everything here, so the result will be shown in the Excel sheet only, not in any other mode, not in any other thing. But if I'm using, if I want that Excel result, whatever the result which is being published in the Excel, if I want to use that Excel thing, to make some statistical calculation in another application, I have to copy paste the answer, or I have to note down the answer and then use it in the other other computational apps. But here, with the help of big data, so it automatically gets generates or gets information, the data, gets the data from each and every file types, and it finally gives the it is a storage space. It's a mega storage space, so it collects everything and keeps safe there. So whatever you want to retrieve from there, you can retrieve. So this is how it works. For example, you can now link your Twitter this thing to to your to any of your mobile app, or you can even link your geographical location. You cannot tag your geographical location in any of your LinkedIn app or LinkedIn profile, or you cannot tag it with your Instagram profile. So whoever is accessing Instagram, or whoever is accessing your LinkedIn profile, so they will come to know where your exact location is right now. So that kind of advancements have come. So these are the characteristics of big data. Say 3 V's. First one is volume, and velocity, and variety. So volume is big data starts as slow as 1 terabyte, and it has no upper limit. There is no upper limit at all. You can keep on adding data. You can keep on adding data after data. There is no limit at all. Then velocity. Big data enters an average system at velocity ranging between, that is a speed, 30 kilobytes per second to as much as 30 gigabytes per second. The speed, the speed of the calculation, the speed of the publishing of the results, whatever you're asking for. So that is the velocity, So 30 kilobytes per second or 30 gigabytes per second. So the result is immediately published, in a fraction of a second. And the third one is variety. Big data is composed of unstructured, semi-structured, and structured data sets. So you get in all three formats: unstructured, semi-structured, and structured data set. So if you want to know what is unstructured big data, semi-structured and structured, you have to know the basics of big data. So how it is done, how it goes, and with a maybe with an example of like the organizational activities or computational models of how it is being done. That's why like I'm giving you a tip on like there are many crash courses, like hardly like a few minutes courses are available. It's available in Instagram and LinkedIn and many apps, even in Facebook. I don't know, like if you are like familiar, if you have a good connection with people, like they may be like sharing uh post on like a free course available on this particular big data, or the free course available on like machine learning. What is machine learning all about? Or you can very well like go to YouTube and like type in what is big data. So you'll get an idea about what is big data all about, and you can even relate it to how it can help your organization, or if you know the technique, how it can help you in your career advancement of your career. So that's how you have to learn and be ahead of your competitors. So approximately 97.2% of organizations are investing in big data and AI. Now the investments have already started, and by utilizing big data, and that's an example, Netflix has managed to save 1 billion per year on customer retention. So they have like customer retention has been like done. They have maintained their customers, and they have generated like a volume of 1 billion in a year in Netflix. So this is how it's going to help, and it will be contributing a lot in many ways in the upcoming future. So any doubts as of now? You must be having many doubts, I know. So don't worry that okay, since I don't know what it is all about, I don't know what is machine learning. Why I don't know what is AI. I don't know what is big data all about. So already I have taken this course. So how will I like get to know all it? Don't worry at all. So even if you don't know, even if you're restricting yourself by from knowing all these things, slowly your organizations like they will also start incorporating these new technologies in nearby future. So obviously in another like 2 to 3 years, you will be getting to know what is all about. So it's like like when computers came into scene. So how many of us know how to operate that? So in the late 2000 only I know how to operate a computer. So it was not prevalent in all the organizations, all not in every organizations. Hardly you can see here and there. But after some time, say after 2010, everywhere, even the small shop owners and like everywhere you can see computers. So they print bill and like they enter the data and everything. So anyhow, the computers they started there, like it was prevalent everywhere. So same applies with these new technologies as well. Even though like if you don't know right now, not a problem at all. Or if you don't want to learn it, not a problem at all. If you want to restrict yourself from knowing all these things, not a problem at all. So your organization, wherever you're working, so they will be like integrating all these any of the new technology in their work environment, and you will be like getting exposed to all these technologies in another 2 to 3 years. So if you have any doubts, you can stay, or otherwise you can leave.